By James Gallagher, health and science correspondent. BBC News Media playback is unsupported on your device. Media caption: and could be of huge benefit to children having cancer treatment. Human eggs have been grown in the laboratory for the first time, say researchers at the University of Edinburgh. The team say the technique could lead to new ways of preserving the fertility of children having cancer treatment. It is also an opportunity to explore how human eggs develop, much of which remains a mystery to science. Experts said it was an exciting breakthrough, but more work was needed before it could be used clinically. Women are born with immature eggs in their ovaries that can develop fully only after puberty. It has taken decades of work, but scientists can now grow eggs to maturity outside of the ovary. It requires carefully controlling laboratory conditions including oxygen levels, hormones, proteins that simulate growth and the medium in which the eggs are cultured. Very exciting that while the scientists have shown it is possible, the approach published in the journal Molecular Human Reproduction still needs refinement. It is very inefficient with only 10% of eggs completing their journey to maturity. And the eggs have not been fertilized, so it is uncertain how viable they are. Professor Evelyn Telfer, one of the researchers, told the BBC it's very exciting to obtain proof of principle that it's possible to reach this stage in human tissue. But that has to be tempered by the whole lot of work needed to improve the culture conditions and test the quality of the oocytes eggs. But apart from any clinical applications, this is a big breakthrough in improving understanding of human egg development. UK scientists edit DNA of human embryos. First monkey clones created in the lab. First three-parent baby born to infertile couple. Image copyright University of Edinburgh. Image caption: a lab-grown, human egg made by scientists. At the University of Edinburgh, the process is very tightly controlled and timed in the human body. Some eggs will mature during the teenage years, others more than 2 decades later. An egg needs to lose half its genetic material during development, otherwise there would be too much DNA when it was fertilized by a sperm. This excess is cast off into a miniature cell called a polar body, but in the study the polar bodies were abnormally large. This is a concern, said Professor Telfer. But it is one she thinks can be addressed by improving the technology. Work on mouse eggs, which was nailed 20 years ago, showed the technology could be used to produce animals. Matching this achievement in human tissue could eventually be used to help children having cancer treatment. Cancer option: chemotherapy and radiotherapy risks making you sterile. Women can freeze matured eggs, or even embryos if they are fertilized with a partner's sperm, before starting treatment, but this is not possible for girls with childhood cancers. At the moment, they can have ovarian tissue frozen before treatment, which is then put back into mature years later if the patient wants children of their own. But if there are any abnormalities in the frozen sample, then doctors will think it is too risky. Being able to make eggs in the lab would be a safer option for those patients. Mr. Stuart Lavery, a consultant gynecologist at Hammersmith Hospital, said this work represents a genuine step forward in our understanding. Although still in small numbers and requiring optimization, this preliminary work offers hope for patients. It would be legal to fertilize one of the lab-made eggs to create an embryo for research purposes in the UK, but the team in Edinburgh do not have a license to carry out the experiment. They are discussing whether to apply to the Embryo Authority for one, or collaborate with a centre that already has one. Professor Azim Sarani, the director of germline research at University of Cambridge's Gurdon Institute, said molecular characterization and chromosomal analysis is needed to show how these egg cells compare with normal eggs. It might be of interest to test the developmental potential of these eggs in culture to blastocyst stage by attempting IVF. Follow James on Twitter.